Welcome to the Cambridge Tech Podcast, talking all things technology from the heart of the UK's tech capital. Here are your hosts, Faye Holland and James Parton.
Hello, I'm Faye.
And I'm James. This week we're so pleased to have on the show Professor Tim Minshaw, who is the inaugural Dr. John C. Taylor Professor of Innovation and the head of the Institute of Manufacturing, otherwise known as IFM at the University of Cambridge. And he's also the head of IFM's Centre for Technology Management. Tim's an award-winning lecturer, a researcher, and writes about manufacturing, innovation and skills, and regularly delivers talks on these topics nationally and internationally.
Hi, Tim. It's great to have you with us today.
Thank you very much for inviting me along.
James started with your job titles. Let's start there. What do they all mean?
So I'm very lucky. I have one of the longest job titles in Cambridge. It's got two parts to it. It's sounding a bit complicated already. The first bit is I'm the Dr. John C. Taylor Professor of Innovation. And Dr. John C. Taylor is an extraordinary individual, and I actually have some of his technology in my hand here, which is, I'll try and explain it so you can see what it is, but I can almost guarantee that everybody listening to this podcast will have used Dr. John C.'s technology at some point in their lives, probably today, maybe even a few minutes ago. So Dr. John C. Taylor invented the electric kettle switch, the little technology that makes sure when your kettle is boiling, it switches off. I'll try and describe it because it's really clever, but really simple. All it is a little metallic disc made of two different bits of metal. It looks about the size of for those who remember coins in our cashless world, about the size of I'm showing my age here, a half penny. Okay. I am quite old. And it bends so that when you switch your kettle on, there's a sort of a click sound. I'll try and make it now. That's the kettle switching on. The water would heat up, steam would pass over this little bimetallic, two bits of metal stuck together, little disc. And as those two metals react, one of them expands more than the other. And if all goes well, it would then go and switch off. So that may not sound very impressive, but every day about 1 billion people are using that technology. It will have saved so much money in avoiding kettles boiling too long. It's actually got a second one of these little switches in it, which makes sure that should you, for whatever reason, try and switch your kettle on with no water in it, it automatically detects that and says something's gone badly wrong here as the temperature rises. It switches it off so that your kettle doesn't melt and catch fire and burn your house down. So on balance, that seems like a pretty good technology that we all need. But the really cool bit, in my view, is that he not only invented the thing, the little bimetallic disc that makes this happen, he also built the machine that makes them. So, the UK is full of great inventors who do amazing things, but to go to the next stage and go, to make this work, I'm going to have to build a machine. And I'm going to build that machine, I'm going to make it work, and I'm going to run that machine, and I'm going to develop the business model that makes sure that this can serve the world's kettle markets in this case. It's huge. And even to this day, there's a machine on the Isle of Man going chunk, 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 churning out these little discs, which are then sent off to factories all around the world to make them into kettles. Just an extraordinary guy, an extraordinary business, an extraordinary opportunity, an extraordinary entrepreneur, the guy is.
So you've not got a lot to live up to then?
No. This is fairly straightforward. And so I'm particularly proud that he rather generously donated money to the University of Cambridge to establish a post in perpetuity for there to be a Professor of Innovation at Cambridge University. And through a series of mistaken identities and awkwardness, I've ended up with that job.
In perpetuity.
Yes.
Perpetuity. I can't
That's
even
easy
say
for you
it.
to say. No pressure there then.
No, I've got to do this and live forever. Blimey.
Yeah.
So the second bit of the job is head of something called the Institute for Manufacturing, which is part of the engineering department, and it's got this rather grandiose mission, which is to manufacture a better world. And some people hear that and go, well, that sounds a bit nah. But we take it very seriously because everything we do has got to be about making things better. It's about improvement. It's about development. It's saying there are a whole load of problems out there and a whole load of opportunities out there. Our job is to make that stuff happen, to solve the problems, address the opportunities. And so very briefly, we do three things. We have a whole bunch of education programs. So we have around 200 students with us at any one time. We have a whole bunch of research activities going on. We have 23 research labs, and we're doing a whole bunch of things from very technological, which I might give a couple of examples in a second, a whole lot of things to do with the management of technology, how you get a business to actually deliver value, and a whole lot of stuff to do with policy to make sure that the support that entrepreneurs and manufacturers and innovators need can actually be delivered. So you've got the education stuff, we've got the research stuff, and that's all about kind of solving difficult problems and giving people the skills they need to go on and help manufacture a better world. But there's a third and really important bit, and that is about helping companies now to develop the capabilities to solve the problems that they're facing. So we do a whole bunch of stuff about direct, what we'd call technology transfer, getting the outputs of our research deployed in companies, be they startups, be they small firms, be they multinationals, maybe not companies at all. We do it for regional governments, national governments, for charities as well, because we feel that's so important to not just think about ensuring the future is strong, but helping people now develop the skills they need to go on and solve those problems.
And can you give us a few examples of that? Because I think that's something we're looking to do on the podcast as well. We talk about all of these great developments, but it's actually how companies then go on to use it. So can you share some of those things?
Absolutely. So maybe just so when I talked about the research is sort of spans technology and management and policy. If we just look at the example of maybe each one of those. So on the technology side, 3D printing is a technology that's got huge potential, huge amount of hype and nonsense associated with it as well. But just a few examples of things we're doing there. One is around, so it can be done with different materials. You can do it with plastics, you can do it with ceramics, you can do it with metals. One of the issues with metal-based 3D printing, and maybe just very briefly just to summarize what it is, it's this technology where you build the object up layer by layer. So you're not cutting things away from a block of metal, so there's no waste. You're not applying huge amounts of energy to kind of deform it in a massive press. You're not melting it and then making it into liquid and casting it. You're doing something that's arguably, in many ways, much more efficient. And it's efficient partly because it uses, depending how you use it, less energy. But even more importantly, you're only producing exactly what the customer wants. So it's got huge potential for what's rather grandly called mass customization. Gone from mass production, going to produce thousands, hundreds of thousands, millions of the same thing. Now we can say, could we produce similar volumes where every single product is different? We're quite a long way from that at the moment, but it's getting there. So a couple of quick examples. One is, can you make them much faster? If you ever go to YouTube and just look up metal 3D printing or metal additive manufacturing, it's quite cool and the sparks fly and it looks great, but it's quite slow. So what if you could make it an order of magnitude faster? That's the sort of challenge we like. So colleagues in our industrial photonics lab are doing things around that. Make it faster. Another group are saying, well, hang on, these printers, you're building sometimes quite big objects, and it takes a long time to build them. It's hours, days, weeks. For big aerospace components, it could be months of printing. And you're only maybe making one specialist thing, or only very few. What if something went wrong right at the beginning when you started making it? All of that effort, all of that energy is lost. The other thing is you won't know until the end. And also, how do you know when it's gone wrong if you're only making one? Because you can't slice it in half and go, yeah, that one was fine. Oh, wait, we've chopped it in half. So instead, you need to do all this non-destructive testing of it. Can you analyze it? But then you might still find out that it's no good. So wouldn't it be great if the printer itself could monitor what's going on and recognize something that isn't quite working and self-correct to modify for that? And so we have a group of researchers who've just published their work in Nature Communication to say, we've done that. They've actually developed a learning engine to allow 3D printers to detect when things are going wrong and move towards being able to self-control as well. That's huge, because then suddenly this idea of a 3D printer, which at the moment needs some quite specialist technical help to make it work in some cases, they get much smarter. The printers themselves get smarter. Therefore, more people can use them, even if they're not, experts in 3D printing. So that's another exciting one. And maybe the last example is a lot of 3D printing involves jetting of fluids or the pushing out of fluid through a nozzle of some form. So you can use that in medical applications to do very clever things around targeted drug delivery. So there's a group of researchers working on targeted delivery of treatments for very hard to treat cancers. One of the hardest to treat is those in your brain. So again, using these technologies to deliver, not just to build an object, but to do something that allows something remarkable to be achieved to save lives. So 3 quick examples of one bit of technology applied in very different ways to hopefully, not sounding too cheesy, make the world a better place.
An IFM would invent those solutions and then license the IP through Cambridge Enterprise for
so we'd have
commercial adoption?
Absolutely. So there's multiple different ways we can do this, but we're also aware that the technology alone is never enough. And that's why we deliberately have designed our research activities to not just be about the technology. We've got a whole bunch of other research groups that are looking at things such as design management, given that new technology. So what does that mean for you designing products? What does it mean for when you start to say, well, what would the supply chain for a metal additive manufactured hip implant look like? That absolutely must be considered in parallel with the technology development. You've got issues around, if you've developed the supply chain, are you building a supply chain that is actually resilient to change? What if a new technology comes along that supersedes that? Or are you making sure you're thinking about all those things? So we do this, let's look at the technology and solve the really difficult problem, but don't just then chuck it over the wall going, yep, we've done our bit. It's absolutely understanding the whole process.
Much more holistic.
Right, absolutely. And a nice, slightly different example might be around, rather grandly called, industrial digitalization. So robotics, automation, autonomization of making stuff, getting the machines to be more self-aware of what's going on. Let's pause for a second. Most manufacturing firms in the UK are small, and many of them don't have the capabilities to become more productive. And we're very concerned that we have some absolutely outstanding manufacturing talent across the UK in a whole range of very small firms, but they don't have the capabilities to take on board the latest production technologies, the robotics, the automation, all of these things, for perfectly sensible reasons. Because is the business case for buying it compelling? And are you confident that you can actually use it once you've got it? So that just wasn't happening. So we have a bunch of people who looked at the problem differently. They said, this isn't about giving people technology and saying, what are you going to do with it? It's about saying, what are the problems you're facing? Let's look at the standard problems that a small manufacturing firm faces. I don't know, something like order tracking. When the customer rings up, can you say with confidence where their product is in your chain? And that very often they'll say, not quite sure, we'll go and find out. Or we've got this machine running, we need to know whether it's not working quite as well as it could, and we need to monitor something. How can we monitor it without actually having someone just standing there looking at it? So we set the challenge of going, okay, what's the cheapest and simplest way that problem could be solved? So not going to great manufacturing automation companies and saying, what kit have you got? You could do that. Instead of which, go to Amazon. GoPro camera, Raspberry Pi controller, a bit of downloadable open source code. Can you make a very simple vision system to just monitor that thing over there and then send a little message to someone who works there on their phone to just go, beep, that machine stopped working. Total cost, a few £100, as opposed to multiple of thousands of pounds to get a full industrial system. And suddenly we see, well, that solves the problem. But it doesn't, because you've still got to have enough knowledge to be able to put that kit together. Our colleagues looked at this and said, well, we could have lots of consultants going out solving that problems in firms. But you go, but there are tens of thousands of firms that need this. How do you scale? It's really hard to scale that kind of a business. So instead, or in addition, they're saying, well, why don't we say, where will people learn about this in a way that naturally links in with those firms? And so by just thinking about that problem, you go, well, through the apprentice program, through the further education colleges, because people who are moving in through vocational training into these smaller firms, if you give them that knowledge when they're doing their studies, they just naturally carry it with them. And then suddenly you go, oh, right, if we could get this rolled out across technical colleges and FE colleges across the UK, suddenly there's at scale distribution of this new knowledge to the people who most need it. And that we think could be hugely exciting. And that's rolling out at the moment. So what we see there is that it's a technical issue, but you're not starting with here's a cool technology. You're starting with what's the problem we want to fix? What's the opportunity? What's the market need? Working back from that to the most efficient solution possible, and then saying, well, that's all well and good. how will the customer best receive it? And really understanding the customer journey, which is, if you're a small manufacturing firm, you haven't got much time, you need to just find a way to get that knowledge into your business to make you as a manufacturer better able to respond to your customer needs. So it's just kind of thinking about the problem slightly differently and recognizing that almost always it's not a technical solution first. It's what's the customer's problem you're trying to deal with there.
And I think that's super important. And it's not rocket science, is it? People can go and create technologies, but if you haven't got a purpose for it, it's just a nice shiny thing that you're really personally very proud of.
Right.
You have to have that use case.
Totally.
Because that's where the relevance comes from.
Yeah.
When you started to describe that, you kind of picked up that point that in the UK, we don't have large-scale manufacturing in a sense. A lot of it's distributed across smaller firms. Is that going to hold us back as a nation?
Well, not necessarily. I mean, you can look at Germany, where there's this massive community of smaller firms, what are they called? The Mittelstand companies, the middle-sized companies, who have been hugely important in Germany's European dominance of manufacturing. So the fact that we have small firms isn't a problem at all. It can be a massive advantage because you can be more agile, more flexible.
Diverse, yeah.
Right, exactly. But they've got to have the capabilities to be really good. So being small isn't the problem. Being good, being productive, being efficient, being able to be as flexible and agile as possible.
And I guess cost effective if you're not delivering at scale as well.
Exactly. So then it's the fit in with existing supply chains, or are you actually trying to do a new thing yourself? So that issue about manufacturing in the UK is, the question you raise there it's such an important one about the nature of manufacturing in the UK. What is it and what are the problems it's facing? So one of the things we've looked at is, you can see the figures, the proportion of the UK economy that is manufacturing, depending how you measure it, comes out at about 10%. So that's still 2.5 million people. It's about half of all our exports come from the manufacturing side. About 2/3 of all the business R&D spend is manufacturing firms. We're number 4 in Europe. We're number 9 in the world. So we're still a significant manufacturer. But it is, compared to the whole economy, it is going down. That's not in itself necessarily bad. So 2 things we looked at. It's going, well, why is it getting smaller? And partly it's because for the last few decades, I guess, manufacturing has shifted. Those big, old, vertically integrated firms where you did everything. You would do the research yourself. You would do the development yourself. You would do the production yourself. You would do the shipping yourself. You'd have your own fleet of trucks. You would have all your own canteen facilities. You would have all of these things. And everybody who worked in that company, even if they weren't making a thing, were still classed as working in manufacturing. They all worked for Rolls-Royce or British Leyland. It was all now, a huge number of those parts of the business, like catering, like transport, is outsourced. So manufacturing apparently has gone down, but the logistics and the catering sector has gone up. And you go, well, no, it was all the same thing.
All right.
So there's that sort of teensy misunderstanding with the statistics. The other bit is, maybe just jump straight back to a Cambridge example, if I may, Arm. So you could go, well, that's not a manufacturing firm. According to the official statistics, you go, well, they are doing intellectual property around semiconductor design and licensing. You go, yes, but that's a critical part of the manufacturing of billions of products around the world. So we would say that absolutely is part of it. So a couple of colleagues got really concerned about this figure of 10% and said, is it really? And they went away and wrote a report, which you can download from our website, which says it's probably more like 20%. And it is not just the fact that it exists, and it's not about it's bigger than we thought or smaller, it's the significance of it. How much of the UK economy is based on the fact that we have a strong manufacturing sector. And that's the thing. We maybe come to this later about the whole business of explaining what manufacturing really is to people who don't care about manufacturing. Do we all understand the role of manufacturing in our lives, in our communities, in our societies?
I think that's a really good point. And especially, I think, supply chain and logistics. That's suddenly become a 6:00 news issue with the disruption we've seen in supply chain due to the pandemic and Ukraine and other things.
Right.
Whereas previously, probably people didn't give it 2 seconds thought. So you're obviously covering the whole end to end through the logistical supply chain element as well.
Absolutely. So to us, there's actually 3 bits to it. One is, we need stuff, right? We can talk about the digital service enabled blah, blah, until we're blue in the face. The truth is, we need physical stuff to be made. Yeah, that's an absolute truth. I'm not, what do they call it? I'm not a manufacturing fetishist who's obsessed by the making of things. Okay, I do carry a kettle switch in my bag at times, but that's a different issue. But it's the economists have shown, it is very clear that if you want a strong, I was going to say strong and stable, we're not going there, an economy that is resilient, that is sustainable, that is equitable, you need to have manufacturing. Manufacturing is a core part of an economy that achieves those three things of sustainability, resilience, and equity.
Picking up on that point, you said recently as well that we're all in manufacturing now. And I think that that's really, for Cambridge, that's really specific because, whether it's chip production, medical devices, every single end user thing that you see. So I kind of want to go back to the question about our capability in manufacturing, because we have got some good news. So CMR Surgical, for example, they've kept their manufacturing actually really local to Cambridge over in Ely. We talked to Scott White, Pragmatic, and he's obviously got manufacturing in the north of the country, and Raspberry Pi are doing production here. So there seems to be a little bit of a switch to bring in more things here. And, we talk to startups and they are really conscious as to where they want the manufacturing to take place. So do you see any changes, any evolution of that?
Absolutely. So there's some work done about the US economy a few years ago, which was pointing out that in the US, a huge amount of manufacturing had been shipped over to China. This is going back a couple of decades. And it was sort of, but that's fine. We're going to do the high value add bit. And you go, okay, there is a logic to that. But as soon as you break the link between the designing the thing and making the thing, you face all sorts of challenges straight away. And if you then spread that distinction not to being the other side of the road or the other side of the county to the other side of the world, you face lots of very practical problems straight away. But also, you're not involved as much in the full process of value capture. You're then kind of handing that to someone else, and they may then find ways to develop it. And what can be happening is you get better and better at manufacturing. So you think you're doing the clever bit over here and you've passed this over to someone else to do the manufacturing. They learn how to do that. They find ways of doing very clever things around that, and they can move on and become effectively one of your own competitors. That's a rather extreme case. But the two key points are having an understanding of what the thing is and what the customer really wants and how it's going to be made is really important. If you want to make a product that the customer really wants and can support and can modify and repair and all those good things, you absolutely need to understand how it's made. And that's really, really clear. And the second bit is just the sheer practical challenges of managing suppliers who are very far away. And it's not to say you shouldn't do that sometimes. In many cases, it's totally the logical thing to do. In other cases, you just go, oh, I've got a problem now, and we've got time zone issues, all that very practical issues about what it's like when you're the other side of the world.
When you're looking to raise money, obviously venture capital can be impatient. So there's always that squeeze on the money you're spending.
Yep.
Like building infrastructure in the UK is going to be quite hard, I would have thought, to sell as a business case to a venture capitalist.
Yeah, I think I do agree. And there's an aversion to manufacturing when it's always compared to software. So you can just go almost, not zero cost of scalability, but comparatively much lower and lower risk as well, because you're not investing in bricks and mortar and machines. And then there's an issue, be great to come back to maybe later, of skills. Have you actually got the people who can do this? So all of that raises, for investors, all sorts of red flags. And yet, seeing the way in which CMR Surgical, Domino Printing Sciences from a few years ago, now part of Brother, I believe, the way in which Alstone, the way in which all of these companies that have a physical product they need to make, absolutely need to understand the full chain of activities to bring that to market. Wow. And the more you disaggregate it, the more you break it up, the more likely it is you'll lose control over something. So I think, exactly to your point, this is totally about recognizing that there is real value to be created and captured if you're involved in manufacturing. Yeah. But it's not for everybody. Yeah. And that's why I'll repeat my phrase about manufacturing fetishism. It's not just, oh, it's a good thing, we should do it. There's got to be a rational decision for doing it. There's got to be a compelling reason for doing it, because it is difficult.
You gave some Cambridge examples there, Faye. I think that's representative of Cambridge being very much a centre for deep tech rather than more the internet style software businesses that you're talking about, Tim, because rightly or wrongly, tech seems to have been caught up in software businesses, and it doesn't really necessarily always take a wider lens across all the other kind of areas where you're employing innovation and pushing forward the boundaries of technology. So maybe we can start to move on to there, because I think you've hinted at it, but maybe manufacturing is a bit of a PR image issue. People think of car plants and steelworks and all of these kinds of things, but clearly that's not where manufacturing is. I mean, what are your thoughts around that in terms of like the perception of engineering and manufacturing?
Right. How long have we got? So if I can just break that into engineering and manufacturing. So one of the things I did a few years ago when I was young and enthusiastic was to say, well, we don't have enough engineers. There's a STEM, science, technology, engineering and maths, but particularly an engineering shortage. And I kept reading all these figures about, I don't know, the UK needs 100,000 more engineers a year. And you go, oh, don't know where that number's come from. Seems rather precise. And we kind of looked at that, and we need people with the ability to solve certain types of problems. Labeling them as engineers or not engineers, I don't think is very helpful. And this is an issue that, it is sometimes of concern. But if we just briefly and elegantly skip over that bit, realizing that a lot of people don't understand, myself included, that I didn't really know what engineering was when I was younger. I hadn't got a clue what it was. There's sort of the scientists and there's other people, but engineers, what do they actually do? And all the sort of caricatures of, it's the people who fix things, as in something's broken, you bring in an engineer. Yeah. Yep, that is a role for a certain type of engineer. All the other stuff about the engineers who create, who problem solve, got a bit lost. I think we're much better at that now. A superb campaign by the Royal Academy of Engineering and their partners called This is Engineering has been really, really good, particularly at certain levels of school activity. So what we tried to do was to then say, well, we should play a part in a more positive image. We started to look at schools and how children learn about these things. And we started going, well, where can we usefully do something? There's so much good stuff out there about what engineers do, and there was a lot out there. And we said, well, what's not being done? So we looked at sixth form, plenty of stuff there. Not saying there couldn't be more. Secondary school generally, quite a lot of work there. Primary, it's this early stage perceptions. And so we would go off and do activities in schools and realizing a number of things. One is, it's not so much just about engineering. It's more, in many of the schools we visit, it's about aspiration. It's about the chance to make a difference. You can be a problem solver. You can make mistakes, and that's all fine. That's all part of the process of making things better, as opposed to the curriculum, which at times says, let's help you get to the right answer as quickly as possible. So a lot of it was around the sort of mindset, engineering mindset approach, rather than, do you want to be an engineer who works in a Formula One team? That's a thing. But no, it was more about the thinking like an engineer. And we found this was great, and we thought we were doing good, and we tried to do good, and we realized there's a really important thing, that it's the teachers in the background who were listening and going, oh, that's really interesting. I didn't realize that. So we worked with the headmasters and the headmistresses of all of these schools. We worked with the faculty of education, where they're training teachers specifically in science for primary, to really understand that the teacher's journey in all this. So how do they fit it in to what's going on? And then really importantly, we realized the children were going home, hopefully excited, and talking to their parents and their friends and going, oh, there's this thing. We realized they are the best agents of change. They've got to have the right message. And so, yeah, we carry on doing that, but it's very localized. And
you've developed all the content for that. The IFM has developed all the content that goes
along with many others. And so we have a wonderful colleague called Neve Fox, and she is the Sharman Outreach Fellow, named after one of the founders of our institute. And her role, as well as her research, is to ensure we have an active program of generating new materials and getting it out to the people who most need it. If anybody wants it, they can have it. It's very open. We're not trying to say the institute does this, it's our stuff. We just want everybody to have it. And then we end up in the slightly sensitive issue sometime around some of the independent schools versus the state schools, where you go, we want to talk to everybody, of course, but you look at the resources that the independent schools have, and it's fantastic. And then you go out perhaps into some of the schools we visited in Finland, very, very different situations. So again, we've decided we want to give the message to everybody, but probably focusing more on primary, particularly in areas of particular need where there aren't many resources. We want to have the maximum impact there. But then we realise it's how far can we travel to get to these schools? The education sector is massively under pressure, and we don't want to do anything that in any way is regarded as irritating for the teachers. They've got such workloads. It's just ridiculous how much work they have to do. So we're trying to find ways to make it smoother. So actually COVID, in a weird way, was a bit of a help, because suddenly we could do it online. And then suddenly the reach of the number of schools, the distance away we could reach was orders of magnitude higher. But it's still not quite enough. And again, it's just targeting schools. So maybe if I can talk a little bit about some of the other work we're doing about trying to change perceptions of manufacturing more generally.
Well, just before we move off that point, obviously if you're operating at the primary stage, it's going to take a amount of time before you see if there's been an impact.
Right.
What's the time horizon of these programs, and what kind of outcomes are you looking for?
So you've nailed a really, really challenging topic. Thank you.
A pleasure.
Which is, if you seek funding to do this, quite naturally, a funder will say, okay, how will you know if this has worked? What will be your measure of success? And you go, well, in about 10 to 15 years' time, maybe some people might have changed decisions they make. And you go, how will you measure that? And you just go, well, we can't. So it's done on faith. It's done on, is this aligning with things that are happening anyway? There's then a whole load of issues, particularly around gender and decisions that are made around the curriculum. And a big one for engineering is physics and maths, which in certain environments will be regarded as not a thing for everyone. And that's assuming you're going to go and do a thing called studying engineering. Yeah. And that is an absolute thing we must support and we need to do more of. But it's back to my earlier point about it's not we need more engineers. We need people who can creatively solve problems with a technical understanding. That very often does not need a degree in engineering. So it's more about not saying, has the number of people applying for engineering degrees gone up? Yes, we'd like to see that. It's, has this message about the way in which you address and solve problems, has that message gone out and changed behaviours?
It's brilliant what you're doing and the focus on primary and certainly those less privileged schools. There are other programs within Cambridge, because obviously this is your own program.
Yes.
So we know and work with Cambridge Launchpad very heavily, and that's what they do for all the other companies. So there might be an Illumina or a Marshalls or a Ninja Theory. There's a whole raft of different companies there that are trying to do the same thing. And I think that's when you get the shift.
Yes.
Because everyone's
Absolutely.
kind of getting that they're doing it on trust to help build the future. And I think when we come on to the last bit of our conversation, we can pick that up again. One random question, why not? So you're trying to inspire the next generation and the next generation. Who inspired you?
Oh, that's a very good question. There's no single person. There's no single thing. Do you mean why I've ended up doing manufacturing, or which bit of the inspiration do you think? Well,
I think also your career has been really interesting because you've been a teacher, you've been a consultant, you've done all of these different things and you've ended up here. Was there one person, or was it just a collection of different things?
Are you very politely asking why is my career a series of random lurches in different directions?
Yeah.
Okay. Yeah, that's a good question. It was absolutely a series of lurches. I think it comes down to growing up in an environment where I was very much encouraged to just do what you want. You've got to try things, always try things, have a go at something. It doesn't work, it doesn't matter. I think that having that mindset early on and having absolutely brilliant primary school teachers. I'm old enough to have gone to a tiny village primary, which had 2 rooms. There was the little class and the big class. And there was Mrs. Miller in the little class and there was Mr. Froud in the big class. And they were teaching everybody from age 4 to age 11. All abilities, all everything in one place. They were extraordinary. I was so lucky to have that environment. And this was a little village primary out in Boughton in Norfolk. And by just always having this positive mindset of, have a go, give it a go. What's the worst that can happen? Was really important. And back in those days, perhaps there was less requirement to follow curricula quite so closely, dare I say. So there's a lot more flexibility. And so you could do experiments and try different things. So I think those, apart from my parents who are absolutely fantastic at encouraging this, having teachers who would just go, give it a go, see what happens, we'll do that. But I know that was of a different time, and it's a very different set of circumstances now where there is more requirement of teachers to follow set patterns. So it's back to that earlier point about empowering the teachers to say, yes, of course you've got to do these things, but actually giving them the freedom and the respect to say, we trust you as teachers to do the right thing for the kids.
Create a safe space.
Exactly, yeah. So I think that, and also having a desire in the nicest possible way to leave Norfolk. And I mean this, I love Norfolk and I'm very proud of coming from there, but it was saying, but for the rest of the world. And so having people who encourage me to say, well, if you want to go to Japan, why don't you go to Japan and see what happens? So I think having people, a whole bunch of people who've not stopped me doing things, I think is really helpful.
Thank you for sharing that. So I want to take us on now to, you have your day job, you speak at lots of things and you write books. So you now have another one that's underway, I believe.
Just to clarify, I am about to write a book. I have produced books academically, but I don't regard that as writing books in that sense. It's sort of a book with a readership of possibly 3, because it's some tedious academic thing that no one, and it's a thing you do, and that's fine. So much as I appreciate being called a writer, I'm yet to prove myself. But I am absolutely determined to give it a go. And if I may just slightly overshare, I found that during COVID, running an institute of 350 people, or no one in academic sense runs anything, being responsible for ensuring that our institute continued to do all its great works around student projects and making stuff happen to make the world a better place, I needed, I believe, what's called a displacement activity. So I went and I found a wonderful person called Anna Porshaisky, who helped me learn how to write non-academically. She beat it out of me to say, yeah, you can do all that academic stuff that's going to have a readership of, 2. If you want to really shift the needle on people's perception and you want to do that through writing, you've got to be better at it. And so I decided, well, okay, so my evenings and weekends are spent doing that. What we're trying to do is to use that, and the vehicle will be a book to try and explain to people who couldn't give us stuff about manufacturing the importance and the role of manufacturing in our lives.
Targeted at adults,
Yep.
children, anyone?
Anyone.
Yeah.
So I did think, I could write a children's book, and then talking to authors of children's books, and you realise the extraordinary level of skill and precision you need to be a writer of children's books. I just thought, that's another league of difficulty, and I have huge respect for those who write children's books. Incredibly hard to do it well. So this instead is trying to say this is I believe it's called a trade book. This is going to be, something for people, and I mean it, who have no interest in manufacturing, but you've got to make it interesting enough to show that it does matter. And in a weird way, COVID provided an impetus for raising awareness of manufacturing. I think we all experienced it, right? Where you went into the shop and either there was a sign saying limited to 1 item per customer of this, or empty shelves. That sort of, moment. So this really forced me to think hard about it, go, do I understand why that's happened? Honestly, myself, do I understand? And then realising there's a whole thing about, well, all these things have been made somewhere. All of these things have been shipped somewhere, and we're now in the process of consuming them to do something with them. And realising those 3 bits are so fundamentally important to our lives, and yet I myself didn't really understand all of the bits and how it fits together. And so I then read things in the newspaper and perhaps hear some of our political leaders making some comments that made me go, I'm not sure that fully reflects an understanding of everything that's going on. I mean, comments about how much trade goes through the port of Dover. It's made me drop my jaw. What's happening in Felixstowe? 40% of all the containerised goods coming into the UK go through Felixstowe and come in on the A14 and a single track railway track. And you go, wow. How do we not know this? And why are we not giving it so much more investment to build up there? I could talk more about Felixstowe docks. I have an unhealthy obsession with shipping containers, but maybe that's for another day.
Yeah, move on.
Yeah.
It feels like it's a really necessary book because, I mean, the other thing that we haven't really touched on, but it's definitely a trend I see with, my children and just society as a general, is just how throwaway we've become. And there's absolutely no thought given to what it's taken to get something to the table or to their wardrobe. Fast fashion is a great example.
Yeah.
Where you buy something for £2, you wear it once, and then either throw it away or send it on one of these websites that have just started up so someone else can then buy it once and then ship it to someone else to buy once.
Yeah.
How is that sustainable? It's insane.
Yeah. And so one of the things to kind of breaking it right down to the things that need doing, all of us need to explain this better, is there's the manufacturing, the production bit, there's a making of a thing. And the first thing is, what are we actually making? Should we be making that thing? Should we be making fast fashion goods that are used once and chucked away? Then there's how do you make it? Are you making it in the most efficient, most resource-friendly way? Then there's getting it to us. And can we be much cleaner at the way we do that? So avoiding shipping containers, there I go again, ships full of shipping containers, using one of the most polluting forms of fuel, bunker fuel, and charging tens of thousands of miles around for something that, did we really need it? And could we shift to renewable energy sources for ships? And that is happening. We're seeing that happening finally now, but it's a long way off. And then the other argument is reduce the distance things travel. Back to the point about what Cambridge might do more local manufacturing, but also think how these new technologies like 3D printing actually mean you can reduce the distance between the producer and the consumer dramatically. You can imagine worlds where you go into a shop, you want some new shoes, do all the measurement of your shoes, choose the design you want. There sitting in the corner is a 3D printer. You go off, have a cup of coffee, wander around a bit, come back, there are your shoes done. No more shipping 10,000 miles each way. No more, I didn't really want that one, I'm going to chuck that away or give it to someone else. You do that. So we've got the making, the moving, and the consuming. That awful temptation as I reach across and pick up my phone in my left hand here, and how many times do I just see something and go, I quite fancy one of those, Amazon, click, buy it, done. Did I really need to buy that? It's just too easy. And because it's so easy, we build systems that make it easy. So we are complicit in this whole machine that is polluting and is doing all these bad things, but also doing some really good things as well. So we don't want to lose the good with the bad. But the madness, you remember whenever it was, a year or so back, the ship stuck in the Suez Canal?
Yeah.
One decision by one person on one ship grinds a significant proportion of global trade to a halt. We have allowed that system to grow. That's all of us.
How fragile it is as well.
Totally.
Yeah.
And the other bit is all the R's, careful how I say that, the reuse, the recycle, the repurpose, all of the things that we really should think harder about. Another colleague introduced me to the other one, which is refuse. That is not a good product to make. Why are we doing that? That just shouldn't be.
Do you also look at the true value of things? Because I have this
getting a bit philosophical here.
Well, so my brother works in food manufacturing.
Okay.
And we have long debates about actually consumers just do not understand the true value of food because the supermarkets discount it so much.
Oh.
And the same applies to manufacturing.
Yes.
Do you look at, along, I guess, with this disposable society that we've become, people actually don't really understand the true value of what they are buying in the sense of what it's taken both in resource and commercial terms to get it to you in the first place?
Yeah. That opens up a whole load of things to talk about. But in particular, yes, I think that the quick answer would be, yes, we, myself, everybody, will undervalue things because it's not clear. There's no friction for things that are more valuable. It's going to be harder to get it. It's all so easy now. And I'm not criticizing anybody with my next comment, but if you look at supply chains and how they're optimized and all of the craziness of things that are good and less good, and look at the last mile world of food delivery, takeaway food arriving, and the great business models of Deliveroo and Uber Eats, all these things. It's incredible how they've scaled their businesses so effectively. But is that the best way to deliver food to people? Having a massively distributed network of individuals on bicycles, electric scooters, two-stroke scooters, whizzing around to do that last mile thing. You could argue, yes, it is. It's absolutely targeted. It goes from that place to you, and it's done. Or you could go, is that really what we should be doing? I totally get people need choice to do whatever they want. I'm not judging anybody at all. I use it myself. But is that the right thing to do? We allow things to move forward because we love them and they're super efficient and they're great. But I think to your point is we probably should think a little bit about that. Is that the right thing to be doing?
So the last thing that I want us to go through, because we could talk about this forever, let's go through. When I last saw you, you were on a stage and you were talking about Cambridge Science and Innovation. And you were celebrating the heritage, but also calling for the next stage of Cambridge evolution. So do you want to expand on that a little bit for us?
I was being a bit pretentious, wasn't I?
It was good though. I like it. Stir the pot. So
Fine. Well, I'll take it as a positive. I'll take it as a compliment. But yes, I was conscious I did kind of go a bit over the top. But the message I was trying and stumbling towards was exactly this point. We, Cambridge, are in an enormously privileged position. Yes, I mean, it is absolutely shocking that we're still the most, if I look at my facts and figures right, the most unequal city in the UK. The difference in health outcomes between the city of Cambridge and heading out into Fenland and out elsewhere in the county is, it's appalling. We must do something about that. So we've got huge privilege in the sense of we have incredibly talented people. We have access to capital. We have these most phenomenal networks, of which, Bradfield Centre is a absolute key part of that. Incredibly talented people, such as both of you, supporting people to do amazing things. We've got all of that. We've got a problem that our local economy has got some challenges with it. But just jumping over that briefly, we, Cambridge, is going to sound a bit pretentious, so I apologise in advance. We need to do something amazing for the world. We should be doing the things that others can't do. We should be setting that ambition to do incredible things, dare I say it, to help manufacture a better world. But we really must. If we can't do it, and if we try and do it, but we measure our success solely on how many billion-dollar companies have we created, that is a metric for sure. And we do need the billion-dollar companies. But that is a measure, an indicator of something else much more important that must be happening. So I think the plea was partly to absolutely celebrate our heritage. There's such talented people who've given up so much to make Cambridge what it is today. We want to respect their legacy and say, well, what are we going to do to make things even better? And I just feel that we're at a really exciting tipping point where we can do something amazing. We've just got to be careful how we line things up to say, let's go for that. What's the big global problem that we want to be involved in solving?
It's a huge question, isn't it? But like you say, if we can't do it here, where can do it? What other place in the world can do it?
Yeah.
So, from my point of view, we've done a lot of things around agriculture. And actually the fun is where you converge the different technologies. Mm-hmm. And so I kind of see that as a really good place for Cambridge, where AI interacts with a different technology or genomics or, what do you think about that?
I completely agree. And in a way saying, there's been a kind of an instrumentation thing going back a few decades. And then there's the microcomputer thing. And then there was the biotechnology thing and they were absolutely, those sectors emerged very rapidly and Cambridge played a huge role in driving them forward. But the complex system world we're in today, it's much more important to see how is technology being deployed to problem areas such as food, such as healthcare. And we see this, as you say, wonderful, powerful convergence of not just bioinformatics with IT meets biology, but the whole idea of how can all these great tools of machine learning and AI be deployed to do incredible things in areas we just couldn't do before, like Helix, for hard to treat rare diseases, using really clever stuff that's been developed from a very deep tech perspective in a sector that's been around for, literally a century or more and doing something amazingly different. So it's sort of getting away from the silos of sectors and saying, what are the things that need solving? And the more we can do to encourage that, the more chance Cambridge has of making a significant series of impacts on the world.
Yeah, well, that's the challenge, isn't it?
It is. This is a very philosophical episode, isn't it?
It's actually a stunned silence there.
It is, yeah. I mean, I guess the only other question I'd maybe like to end on is, so what's your confidence level in Cambridge being able to step up to the plate and achieve that?
Very high. I think if we've got the ability to do something amazing here, we've got the people with the talent, and I mean that from a technological and scientific perspective. So if I just very briefly rewind the tape to when I was working 20 years ago at St John's Innovation Centre, it was really interesting talking to the entrepreneurs who were there and trying to do what we could to support them. there would be this perception that we're really good at the technology if only we had more people who had a background in marketing and sales and business development to help us. But there weren't enough of those people around. There were some really good ones, but there weren't enough of them. I don't see that made as a comment so much now at all. So we've been able to attract in, because of the rolling success of Cambridge, that thing has gone away. So hang on, we've got the scientists and the technologists. We've got the investment, absolutely. We've got this incredible pool of those who can convert technological ideas into market opportunities and make that two-way conversation go. I think we're way ahead of where we were before. So given all that, given the scale of the problems we're facing, if we can't do it, who can?
Next week, we have Rebecca Beckenut and Rosa Del Campo from Locate Cambridge, which is the inward investment arm of GrowthWorks. They were instrumental in keeping CMR Surgical here in the region. So it's going to be interesting to see, after Tim's comments, how they attract businesses to the region and how they keep them here. Then after that, the next episode is, yes, it is an episode on Christmas Day. And my plan is we're going to record it with both Carl and James, fully tinselled up with a Christmas hat on. So look out for that one too.
Today's show was produced by Carl Homer of Cambridge TV and supported by our media partner, Business Weekly. The Cambridge Tech Podcast is available on all major podcast platforms and on cambridgetechpodcast.com. If you've enjoyed this podcast, please give it a 5-star review. It will really help others discover the show.
If you are a startup looking to grow in Cambridge, the Bradfield Centre offers a range of flexible membership packages which put you in control of your office and home working mix. There's a vibrant, collaborative atmosphere, on-site cafe, plenty of green outside space, and regular member social events. For more information, visit bradfieldcentre.com or call 01223 919 600.